kind of the verse that is the core of reasons to believe is 1 Peter 3:15. Always be prepared to give an answer to everyone who asks you to give the reason for the hope that you have, but do this with gentleness, respect, and a clear conscience. And that's the mission of reasons to believe, is to prepare good reasons, develop good reasons that you can share with people who are looking for the reasons that the hope that you have in Jesus Christ. But we also have core values that we emphasize within reasons to believe: humility, courage, gentleness, and respect. Because when you share your faith, people will often listen more to your demeanor than you do your words. And this is exemplified in many of the public debates we've seen. I think the one that has been the most popular is a debate I did with the British atheist chemist, Peter Atkins. You can just put Peter Atkins' name in or my name in, it'll pop right up, and you can see the demonstration of 1 Peter 3:15. But I've got another reason as a pastor for emphasizing this passage in Peter. And by the way, it's in the context of 1 Peter 3 and 4, 2 whole chapters where Peter is basically explaining how we can effectively share our faith. But the principle is this: if you will prepare good reasons for your faith and hope in Jesus Christ, and are able to deliver those reasons with gentleness and respect, God promises to supernaturally send people to you that in advance he is prepared to hear and respond to your good reasons. You see this all through the book of Acts. But if you read the book of Acts, you notice there's no conclusion to the book of Acts. It just ends midstream. And the principle there is the book of Acts is still ongoing. It didn't end with the first century. It didn't end with the apostles. It's something that goes on today. And I run into a lot of theologians who don't believe that. They say that those kinds of miracles stopped in the first century. My exhortation is, put it to the test. Actually put into practice sharing good reasons with gentleness and respect, and you'll personally witness the miracles that you see in the book of Acts. When it happens the first 4 or 5 times, you might think maybe this is just coincidence. But after it happens more than 100 times, you realize this is the book of Acts in operation. And I'm just going to share with you one story. And I've written a book on this, Always Be Ready, where we literally share hundreds of stories. But this is just one story. I was in the San Francisco airport waiting for a flight to the East Coast. And every 15 minutes they would come on and say the flight's been delayed. And you kind of know what's going on. The flight's already been delayed by several hours, but they keep telling the people in the waiting room, 15 more minutes and we'll board the plane. Then you come up to 15 minutes, another 15 minutes. This had gone on for a couple of hours. And then they called my name, and I said, uh-oh, I got a cheap ticket. This is not good news. But I walked up there and they said, we noticed that you're traveling by yourself. Are you okay if we change your seat? Because we have a family and needs to sit together. I said, you can put me anywhere you want on the airplane. And so they handed me a new seat. I looked at it and it was seat 2A. And I said, boy, that's first class. I'm going to actually travel first class. This will be interesting. So I get into my seat when they finally did board the plane. And a gentleman comes in and he's in the seat next to me. And he introduces himself and he says, I'm from Germany, I'm a quantum physicist, and I'm an atheist. Who are you? And I later found out that's rather typical of German academics, that they not only tell you their discipline, they tell you their worldview perspective. And I said, well, I'm not from Germany, I'm from Canada. I'm not a quantum physicist, I'm an astrophysicist. I'm not an atheist, I'm a Christian. And he said, this is going to be a really interesting flight. And he proceeded to ask me questions for the next couple of hours. So that's the story here of, about this quantum physicist. And let me move this through here. His first question that he asked me, he said, If there's a God, why would he bother to make 2 trillion useless galaxies? Wouldn't one galaxy be enough? Matter of fact, why a galaxy? Why not just have one star and one planet orbiting that star? And I imagine a lot of you have been asked this question. Why 2 trillion useless galaxies? And what I shared with him is that the universe's mass determines what elements you get. And he says, oh, what do you mean? And I said, well, the greater the cosmic mass density, the more hydrogen is fused into helium during the first few minutes after the cosmic creation event. I shared with you yesterday that we can prove that there's a beginning to space and time. There was a moment at the beginning of the universe when all the space-time dimensions were squished into an infinitesimal volume. And the principles of thermodynamics is that when you make something smaller, it gets hotter and hotter. And so at the beginning of the universe is nearly infinitely hot. But there's this release of space curvature. The universe expands. As it expands, it cools down. And when it's between 150 billion and 17 billion degrees is when you get hydrogen being fused into helium. And I said, if the mass of the universe is too great, then the universe will spend too much time in that temperature window between 150 billion and 17 billion degrees. Or if it's less massive, if you don't have those 2 trillion galaxies, where that makes up 0.25% of all the stuff of the universe will spend so little time in that temperature window that it will only make a small amount of helium from the hydrogen. And if you have too little helium, when stars form, they'll not be able to fuse any of that hydrogen and helium into elements heavier than helium, which means that the periodic table would look like this. And boy, this would sure make passing a chemistry class easy, right? But the problem there is you have no carbon, no oxygen, no nitrogen, and no possibility for life. On the other hand, make the universe the tiniest bit more massive, and this is what the periodic table looks like. You make so much helium out of hydrogen in those first few minutes after the cosmic creation event that when future stars form, they quickly fuse all that hydrogen and helium into elements heavier than magnesium. And in that case, you also have a universe with no carbon, no oxygen, no nitrogen, and no possibility of life. You have to fine-tune the mass of the universe exquisitely to get the following periodic table, where you got the light elements, the heavy elements. I mean, for example, in your human body, there are 22 of these 92 elements. You need all 22 in order to be able to survive, and they're all over that periodic table. And he said, well, to what degree do you have to fine-tune the mass in order to get the elements so that we could be actually flying on this airplane? And I said, well, it's about 1 part in a quadrillion, 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 quadrillion. So the universe has to be incredibly fine-tuned in terms of its mass in order for there to be the possibility of life. So now he said, okay, I understand now why the universe has to be as big as it is, but tell me, why does it have to be so old? Why 13.79 billion years? If there's a creator, couldn't he have done it a lot faster than waiting all that time? And I said, well, the creator wanted us to be able to observe the universe. And I said, in astronomy, as I mentioned yesterday, we have no access to the present. We look at the sun, we see it as it was 8 minutes ago, because that's how long it took the light to travel to us. The farther away we look, the farther back in time we see. And we now have telescopes powerful enough that we can actually look all the way back to the creation event itself. We can literally directly watch the universe coming into existence. Now, I've been accused of making that an exaggeration, and it is true. I can't show you an image of time equals 0, but I can show you images, and you'll see them in my books, that show you the state of the universe when it was 100 billionth of a trillionth of a trillionth of a second old. That's pretty close to the cosmic creation event. And it's our ability to directly witness the cosmic creation event where we get the most compelling and rigorous scientific evidence that there must be a creator beyond space and time that created the universe and designed the universe so that we human beings could exist. But I shared with a quantum physicist, here's the problem. If we were created any earlier in the history of the universe, light from the cosmic creation event wouldn't have adequate time to travel on the space surface of the universe and reach our telescopes. And it says, moreover, the universe is expanding. And so the different stars and galaxies are getting farther apart. If we were here any earlier, the stars would be so close together, we'd only be able to see a limited distance out into the past history of the universe. So we can't be here any earlier. And he says, well, what if we're here any later? And I says, well, right now, the farthest reaches of the universe are moving away from us at barely under the velocity of light. And I shared with you yesterday that dark energy means that the universe expands faster and faster with every year that goes by. It won't be long before those most distant regions will be moving away from us at greater than the velocity of light. And when that happens, we'll no longer be able to see the cosmic creation event. We're here at the only time where we could read the entire book of nature from the cosmic creation event all the way through to the present. So if we were created later or earlier, we would not be able to witness the cosmic creation event. We'd only be seeing maybe 70% of the past history of the universe. As it is, we can see 100% of the history of the universe. And then he said, well, are there any other reasons why the universe has to be 13.79 billion years old? Well, I said, given the laws of physics that the Creator chose, yes, there are. And I'm only going to give you one. I shared with him several. But one I shared with him is that if you want a planet with a strong magnetic field to protect us from solar and cosmic radiation, and strong enough plate tectonics that we get continents and not just have an ocean all the time, it's crucial that we be living on a planet that has a huge abundance of uranium and thorium. And stars make uranium and thorium. But uranium and thorium are radiometric elements. In other words, they decay after they've been made. And so when the universe is young, the stars are aggressively producing uranium and thorium, but the older the universe gets, the less and less uranium and thorium these stars make. And then they're decaying. And what this tells us is that there's a peak time in the history of the universe where uranium and thorium are maximally abundant. And if you look at that graph there, what you see that happens when the universe is a little more than 9 billion years after the cosmic creation event. What's interesting about that particular date is that's when the solar system formed. It formed at the moment that uranium and thorium were hitting a maximum abundance in the history of the universe. And therefore, we wind up with a planet that is super endowed with uranium and thorium. In fact, what you'll see in several of my books, especially my book Improbable Planet, is that planet Earth is uranium thorium champion of the universe. We have 630 times as much thorium as we see in other rocky bodies in the universe, and 340 times as much uranium. And one reason why is we formed at the just right time. There's actually several other factors that are necessary to get us super endowed. But then my quantum physicist friend said, well, why didn't God put us here 4.5 billion years ago when we're at that 9.2 billion? And I said, well, there's a problem. Stars are like human beings. They're unstable when they're young, they're unstable when they're old. They're maximally stable when they're middle-aged. And for we human beings, we're stable for about 90% of our lifetime. For stars, that stability period is a very tiny percentage of its lifetime. So for example, if we look at the flaring activity of our star, the sun, it looks like this. And the vertical scale is logarithmic. And so early in the history of the sun, the flaring activity was 100,000 times greater than it is today. But as the sun ages, it stabilizes. And we are here at the time when the flaring activity is minimal. If we were here even 100,000 years earlier, the flaring activity would be too high to sustain global human civilization. And so if you look at that 4.5 billion, add it to 9.2 billion, what do you get? You get a universe that's about 13.8 billion years old. So that's why the universe has to be the age that it is, one of several reasons why. And then he said, well, you're an astronomer. You know that darkness dominates the universe. Why would God need to have the universe as dark as it is? Why is the universe so dark? And being a quantum physicist, he was aware of the things that I was aware of, that dark energy makes up about 70% of all the stuff of the universe. Dark matter makes up about 23%, ordinary dark matter, another 4.5%. All the stuff we see through telescopes, the stars, the galaxies, the planets, the comets, the dust, the gas that we see, it all adds up to only 0.27% of all the stuff of the universe. The universe is predominantly made up of dark matter and dark energy. But as I shared briefly last evening, the dark stuff has to be exceptionally fine-tuned in order to make possible the existence of life. If you make the dark stuff just different by 1 part in 10 to the 122nd power, no physical life is possible anywhere. And I shared with you yesterday, we can compare that fine-tuning with the very best example of human engineering and design achievement, and dark energy has to be fine-tuned to a factor 10 to the 97 times greater than what we human beings are able to manifest. But I said, it goes beyond that. I said, we just talked about how we have to be here at a precise time in cosmic history to be able to read 100% of the past history of the universe. We also have to be in an exceptionally dark place. And planet Earth is in the darkest place in the entire physical universe where physical life is possible. Yes, there are darker places in the universe, but those are places where no life could possibly exist. So for example, this is our Milky Way galaxy. We're not in a central location. I mean, my quantum physicist friend said, hey, the Copernican principle, we're not special. We're not at the center of anything. I says it's crucial we not be at the center of anything in order for us to be able to observe the universe. If we're anywhere near the center of our galaxy, there'd be so many stars in our vicinity, we'd only be able to see out a few light years. But where we are right now is in between the Perseus and Sagittarius spiral arms, halfway between those arms. And that's the place where we have a dark enough sky that we can actually see out into the entirety of the universe. And we're actually in a favored location. We're not at the center, but we are in a favored location. We're at what's called the co-rotation distance from the center of the galaxy. I mean, stars obey Newton's laws of motion. The farther they are away from the center of the galaxy, the more time it takes to make a revolution around the center of our galaxy. For our star, the sun, it's 250 million years to make one trip around the center of the galaxy. So the stars move at different rates depending on their distance, but the spiral structure is rigid, and so it rotates, and it rotates at a rate of about 250 million years for every rotation. We are at the co-rotation distance, and because we're at the co-rotation distance, we cross spiral arms very seldom. Now, it would be bad news if we're exactly at the co-rotation distance, because in that case, mean motion resonances would cause us to be violently kicked out from that position. Where we are is just inside the co-rotation distance, which means we don't get kicked out, but we do cross spiral arms. But we only cross the spiral arm once every billion years. And the last time we crossed one was 500 million years ago. So right now, we're halfway between. The optimal place for doing observational work. And then we look at our star. And how many of you ever heard of the water habitable zone? Okay, that's NASA's mantra. we're going to follow the water because that's how we're going to find life. Because water is an essential ingredient for life. Well, it is, but it's only one of hundreds of essential ingredients for life. But their whole point is planets will have water on their surface only if they're at a certain distance from the star. So there's got to be a distance from the star where you're between the freezing point of water and the boiling point of water. That's called the liquid water habitable zone. But NASA defines it very generously. The possibility of a planet having liquid water on its surface over maybe a square kilometer for 1 month. Well, if you got water on a square kilometer for 1 month, that's really not a good circumstance for life. You really need a lot more water, and you need it there for a long period of time. And so if you're saying, okay, how narrow is that liquid water habitable zone if we're serious about life existing on that planet? Well, it kind of looks like this. And actually, that's way too generous. It really looks like this, where it's so thin it doesn't even show up there. Now, if you look on the NASA website, they go back to this circumstance here, where they have this very broad liquid water habitable zone. They assume this is the only requirement for habitability, and therefore you'll see on their website there may be as many as 40 billion habitable planets in our galaxy alone. And therefore the Star Wars story might really be true. There could be all kinds of sites where life can possibly exist. However, as you've just seen, the liquid water habitable zone is nowhere near that generous. Moreover, it's not the only requirement for habitability. So for example, it's crucial that we have just the right ultraviolet radiation coming in from our star, the sun. If we got no ultraviolet radiation, there's 3 crucial proteins that can't be manufactured. On the other hand, too much ultraviolet radiation will kill you. That's why you have to wear sunscreen in order to protect yourself. But we happen to be orbiting a star where the ultraviolet radiation is sufficient to make sure that those proteins can be manufactured, but not so intense that the ultraviolet radiation would kill us within a few minutes. But here's the problem. Stars less massive than the sun, the ultraviolet habitable zone is inside the liquid water habitable zone. And for stars more massive than the sun, the ultraviolet habitable zone is outside the liquid water habitable zone. And so the quantum physicist is talking to me, he says, you mean there's more than one habitability requirement? And at that time I was on the flight, I said, well, actually there are 11. Today we know of 14. We're discovering about a new habitability requirement every year. So today the list stands at 14. And I describe them in detail in my latest book, Design of the Core, which was released just 6 weeks ago. But I said, even if all you look at is the ultraviolet habitable zone and liquid water habitable zone, that 40 billion that NASA talks about goes down to ones you can count on a single hand. And then you throw in the others. Now, we have found 5,000 planets outside of our solar system. Of those 5,000 planets, none exist in even 3 of the 14 known habitable zones. And of all the planets we know to exist, only 1 exists in 3 out of the 14, the same one that exists in all 14 habitable zones. For a planet to be truly habitable, it must simultaneously reside in all the known habitable zones, all the known planetary habitable zones, all the known galactic habitable zones, and all the known beyond our galaxy habitable zones. I described that in detail in Design to the Core, but I just shared a few of them with the quantum physicist. And he says, fine, I think you've persuaded me in that, but here's my really big problem. You know, the universe is the most entropic system we know of. We talked about yesterday how there's this universal law of decay, what we physicists call the second law of thermodynamics, what lay people often refer to as Murphy's Law, how everything is in a state of decay. But the quantum physicist says, look, you're an astronomer. You know the universe is by far the most entropic system that we can see anywhere in science. Why all that decay? And for that matter, why do we humans have to be subject to so much decay? If this God of yours exists, who's all loving and all powerful, couldn't he reduce the level of decay? So why would your God subject us to so much decay? And we spent about 30 minutes discussing this on the airplane. I'll just cut to the chase. I said there are physical reasons and there are spiritual reasons. And he said, well, give me the physical reasons first. And then I gave him a whole bunch, but I'll give you just a couple here. The decay rate is not so high as to discourage productive work. We need decay to have stars. Without this laws of thermodynamics, we wouldn't have stars that would be burning. Without that law of thermodynamics, plants wouldn't be able to manufacture food. Without that law of thermodynamics, we animals would not be able to consume food in order to transform that into work. But I said, the decay rate is not so high as to discourage us from productive work. And my wife is always on my case about yard work, and I have a hard time being motivated to do the yard work because I can spend all Saturday afternoon getting the backyard exactly the way my wife wants it. 2 weeks later, I got to do it all over again. The rate of decay just is very evident. I prefer to write books because the decay rate is about 50 years, whereas with my backyard it's 2 weeks. But I also shared with him the decay rate is not so low as to let human sin and evil go unrestrained. And he said, what do you mean about this? So I says, if you actually look at the Bible and chapter 3, the third page of the Bible, you see a story of God creating the first man and the first woman, and they're in a state where they're not experiencing any sin and evil. But then they rebel against God and they introduce sin and evil into the world. And what does God say to them? Because of your decision to directly experience evil, I think God wanted to instruct them about evil, but they chose to personally experience evil. And he says, because of your decision, from now on, you're going to be experiencing more pain, more work, and more wasted time. And if you're familiar with Genesis 3, God says to the woman, you're going to be experiencing more pain in childbirth. Now, it's not pain for the first time. Pain was always there. But he says you're going to be experiencing more pain. And, I come from a family of men that are way taller than I am. I'm the shortest man in my family. And my wife is only 5'4", and she's slim like I am. And so when we were having our first child, the obstetrician said maybe 6.5 pounds and maybe 18 inches, while our firstborn was 9 pounds, 2 ounces, skinny, and 23.5 inches long. My wife had a very painful childbirth, and our second son was even bigger. So, but years later, she told me, when we look at Genesis chapter 3, it says that the man will have more work. But it says, I notice we women get more work too. It's not just the men. And he says, and men have pain in childbirth, just like women have pain in childbirth, because he says, the worst thing about the pain in childbirth is not what happens when the baby comes out of the womb. It's watching your children grow up and become teenagers and adults, and seeing them do things that you know are counter to their best interests. That's the real pain of childbirth, watching what happens when they sin, and knowing that could have been prevented. And then you look at the book of Ecclesiastes. It makes the point that as we sin, we wind up wasting time. And because of the laws of physics that we're subjected to, gravity, thermodynamics, electromagnetism, the strong and weak nuclear force, those laws of physics are optimally designed to guarantee that the more sin we commit, the more pain we're going to experience, the more work we're going to do, and the more time we're going to waste to undo the damage that all of our sin has generated. And notice we're biologically designed so that none of us likes extra pain, extra work, or wasted time. And so the laws of physics are actually in place to powerfully motivate us to avoid sin and pursue virtue. But in the process, we discover we can't overcome our natural tendencies to sin. But that's God's way of telling us, you need external help. You cannot deliver yourself from this pain and work and wasted time. We hate all that extra pain and extra work and wasted time. But we realize I can't do it on my own. I need external help. And that's what you see in the book of Job. Job realized that he didn't have within himself the resources to do what he knew he needed to do what he needed to avoid extra pain, extra work, and wasted time. But he says, I look out at the creation. I see the beauty of the creation. I see the abundance of what God has provided for all of his life forms, and especially we human beings. There has to be a God, and that God must be extraordinarily powerful, extraordinarily intelligent, and very caring and loving. Look at how he's provided. And based on that, he said, I know that my Redeemer lives. I know that he is prepared to do for me what I can't do for himself. So thousands of years before the second person of the Trinity, God the Son, the one who created and designed the universe, thousands of years before he came to earth and gave the message of salvation, Job, thousands of years earlier, figured out, just based on what he saw in nature. God is powerful enough, loving enough, and wise enough to be able to do for me what I can't do for myself. I don't know how he's going to do it, but that's where I'm going to put my trust. And what does he say in the 19th chapter? I know that my Redeemer lives, and I will see him in the last day. I will see him in my flesh with my own eyes. So he had the confidence of the assurance of his salvation. God literally designed the universe, earth, and earth's life for the redemption of billions of humans and the eradication of evil. I briefly closed out last night with a conclusion that's from my book, Design to the Core. Now, when we look out at the universe, at all different size scales, we see it's been designed to make possible the existence of life, but even more so, in particular, designed to make it possible for us human beings, not only to live on planet Earth, but to be able to thrive on planet Earth, and build up a population of billions. But the greatest fine-tuning evidence of all is the recognition that everything in the universe and all of its components, all of the events in cosmic history, have been fine-tuned to make possible the redemption of billions of human beings from their sin and evil. We see it in the characteristics of the universe, our super galaxy cluster, our galaxy, the local group, the local fluff. We see it everywhere within the universe. Now, this conversation with a quantum physicist went on for 2 hours. And he asked me 8 questions. I just share with you a few of his questions. But he says, you have to share with me, how come you got such well-prepared answers to my questions? And I says, well, the 8 questions you've asked me over these past 2 hours are the chapter titles in a book I wrote. And he said, I don't believe you. And I says, well, I just got back from a speaking tour. I only got 1 book left in my briefcase, but it is that book. So I showed him this book, Why the Universe is the Way It Is. He opened up the table of contents and says, yeah, those are my 8 questions. Moreover, they're in the order that I asked them. And I said, would you like a copy of the book? And he said, yes, I really would. So he took a copy of that book and he said, look, and his English was flawless, but he said, do you have anything in German? And I said, well, we do, but the only thing I got left in my briefcase is a DVD. And it's called Journey Toward Creation. But it included the documentary in 11 different languages, including German. So I was able to give him this copy of Journey Toward Creation. Now, what was interesting, I only had 2 items left in my briefcase, but they happened to be precisely the items that German quantum physicists needed and wanted. And as we walked towards baggage claim, he said, I've just calculated the probability that a Canadian astrophysicist who's a Christian would be seated beside a German quantum physicist who's an atheist on an airplane. He says, it's about 1 chance in 2 billion. I know what happened today was not an accident. Now, I've never had any other contact with this German quantum physicist since. I did give him my business card, but I've not heard from him. But what I share with people is this. You plant seeds, and you may not be able to see the fruit, or you may have to wait a long time to see the fruit. I've now published 22 books. Number 23 is in the works. But it's such that I tell people, often I'll be speaking at an event like this, and someone will come up to me and said, I read your book 25 years ago. It brought me to faith in Christ. And now I'm here to tell you that it brought me to faith in Christ. And so, if you will practice sharing your faith, sharing good reasons for your faith and hope in Jesus Christ with gentleness and respect, and you keep it up consistently, you will see the tip of the iceberg. The seeds you plant are not in vain. They do bear fruit. And for example, I'm waiting for the time that I'm with the Lord when I'm going to be able to meet a street preacher. When I was about 10 years of age, my parents took me into downtown Vancouver to do some shopping because they couldn't get a babysitter. They dragged me with them. And as we were going into the department store, there was a street preacher. And my parents said, we got to get away from that fanatic. So they dragged me away, but I heard about 15 seconds of what he had to say. And there were 15 seconds that I didn't forget. Years later, that had an impact on bringing me to faith in Christ. The seeds you plant will bear fruit. The heavens really do proclaim his righteousness, and all peoples have seen his glory. And again, you can get this book, Always Be Ready. It may be at the table outside, I don't know, but you can get a free chapter at reasons.org/Ross. And the free chapter we're giving away is where I tell stories of what happens when I'm on an airplane. And one reason why I know this is God performing miracles, half of the conversations I have with people in airplanes, a little more than half, are with people who have doctoral degrees in science or doctoral degrees in theology. And I think you're all aware that does not make up half of the U.S. flying public. Maybe 0.05%, but God knows who I am, he knows who they are, and he puts us together. Now, one of the stories I tell in the book, Always Be Ready, is of a friend of mine who was in the Mormon faith and became a Christian. And he says, and he flies almost as much as I do, but he says, when I'm on airplanes, it's amazing how often I'm seated beside a Mormon or someone who has become a Jack Mormon, where they've left the Mormon faith. God knows who they are, he knows who he is, and God puts them together. God does that. And so the promise is, if you will prepare good reasons for their faith and hope in Jesus Christ, then he will supernaturally bring people to you that he's heard and prepared in advance to do that. Now, I've shared these stories in my church, and I remember running into some skeptics. And one was a young man, new Christian, and I said, well, just come with us. And I said, I don't guarantee it's going to happen every time. But I would take people in our church, and we would just go cold turkey, door to door, and talk to people. Now, we did it with gentleness and respect. If they didn't want to talk, we'd walk away, and we never promoted our church. We were simply there to answer their spiritual questions. But one evening, I was with this young man, and we had gone to 20 doors, and nobody was home. And I said, hey, it's almost 9 o'clock. It's time that we call it a quits. And he said, please, can we do one more? I says, okay, let's just do one more. We walked up to this place. It was really dark. And we opened up this gate, and there was this big German Shepherd dog there. And the German Shepherd dog guided us all the way to the front. Turned out it was a 5-acre estate, and it was pitch black. And so the dog got us to the front door. We knock on the door. The man opens the door and said, how did you get here? And he said, well, your dog showed us the way. And he said, didn't you see the sign at the gate? I said, no, we didn't see the sign. He says, it's a big sign, and it's ringed with lights. There's no way you could have missed it. I said, well, somehow we didn't see it. And he said, well, didn't our dog bark very loudly when you approached the gate? He said, your dog didn't bark at all. and said, well, when you went through the gate, did our dog pin you to the ground? I said, no, the dog guided us right to the front door. And he looked at us and stared and said, you two wouldn't be Christians, would you? And I said, well, why do you ask? He says, because my wife and I and our 3 children, we have been praying for more than an hour this evening that God would send Christians to us to tell us how we can become Christians. And he invited us in. He says, we got a lot of questions. So for 30 minutes, he and his family peppered us with questions, and we answered his questions. And I could tell that their doubts had been assuaged. And so I invited them to join us in praying to receive Jesus Christ as Creator, Lord, and Savior. All 5 of them committed their lives to Jesus Christ that evening. And then we talked a little bit. And by the way, their dog was seated beside me while they were praying. And the man said, our dog never does that. And then he said, I want to show you something. He took us out to the gate. And there was this big sign warning us that there was a trained attack dog on the premises. And the lights were bright. And I remember the young man sitting beside me saying, this is just like the book of Acts. God blinded us to the sign, God blinded us to the light, and God took control of that dog and got us to the front door. And I said, yeah, you're right. It's just like what you see in the book of Acts. That's one of many dozens of stories I could tell, but I want to reserve the rest of the time. We got about 18 minutes for any questions that you have. And like last night, I'll take questions on any topic, whatever you want to raise. It doesn't have to be based on what you heard. And in my final session this afternoon, I have a plenary at the end of the day. I'm going to go into detail about exactly how the laws of physics and the universe are structured to eradicate evil once and for all, and what the physics of the new creation will be like. I mean, we know what the physics of the present creation is. What is the physics of the new creation going to be like, and what is our life going to be like in the new creation? So that'll be the plenary at the end of today. Any questions or comments? And by the way, I appreciate if you come to the microphone, because this is being recorded. Yeah, you can raise the microphone up, so because you need to have the microphone about 4 inches from your mouth.
Okay. So I had a question about the rotation of the Earth on its axis.
Yes.
And how is it possible that that's been spinning like that for, I guess, billions of years without running out? Wouldn't the atmosphere sort of act as friction, or?
Right.
I'm not clear on how it keep going.
Well, the atmosphere does act as friction that has an impact on slowing down the rotation period, but it really is trivial. The biggest factor slowing down the rotation rate of the Earth is the tidal friction it experiences from the moon and to a lesser degree from the sun. So the moon is sufficiently close to us that the gravity it exerts on the near side of the Earth is stronger than the gravity in the far side. And that does act as a brake to slow down the rotation rate. And it's such that we physicists have to adjust our atomic clocks every New Year's Day. But we only have to adjust it by a couple of microseconds. So that tidal friction is slowing down the rotation rate, but it's slowing it down at a relatively gradual rate. Now we do know that the moon-forming event, when Theia collided with the proto-Earth, and resulted in Earth becoming bigger and forming the moon, that spun up the Earth's rotation rate. At that time, the Earth had a rotation rate of about 2 hours per day. Now it's 24 hours a day. 150 million years ago, it was 23 hours a day. 150 million years from now, it's going to be 25 hours a day. And you might be encouraged, with every year that goes by, you get a couple extra microseconds to get your work done. So if you want to know why you're being more productive every year goes by, well, that's what's happening. Now, what's interesting is that if you want humans on planet Earth with global civilization, it needs to be 24 hours a day. If it's 23 hours a day, the cloud systems become too laminar, and so you don't get an even rainfall distribution over all the continental land masses. On the other hand, at 25 hours per day, it's going to be too cold in the middle of the night and too warm in the middle of the day. the temperature differences will become more extreme. The optimal rotation rate for human civilization is 24 hours. Another reason why God put us here at precisely the time in the history of the Earth, when the Earth is 4.5662 billion years old. We're here at the precise time. Yes?
Yes, Doctor. Could you talk about, you talked yesterday or last night about the creation and its bondage to decay and the significance of that. Could you go through Romans 8:21 and talk about how that plays itself out? My second question is a very simple one for you, which is why do uranium and thorium matter?
Well, uranium and thorium matter because they have long half-lives. Thorium, half of it decays over 14 billion years. With uranium, it's 4.4 billion years. So they last a long time, and when they decay, they produce heat. And it's the heat we get from that super endowment of uranium and thorium in the interior of the Earth that keeps our liquid iron core liquid, because if it ever solidifies, that's the end of our magnetic field. So we need that internal heat. Now, that's not the only heat source. Earth also has a lot of internal heat because of that collision event between the proto-Earth and Theia. So we got two heat sources, the radiometric decay of uranium and thorium, and to a lesser degree potassium. That's another long-lived radiometric isotope. And then the heat that we get from the moon-forming event. And so that produces the magnetic field, but the heat also drives the plate tectonics. And one of the things I put in my book, Improbable Planet, is that planet Earth may be the only planet in the entire universe that has long-lasting, strong plate tectonics. Bigger planets are going to be a problem, smaller planets will be a problem, and planets that don't have the heat of accretion like the Earth does, or the huge quantity of uranium and thorium will be a problem. And your other question was about Romans 8. And the relevant passages are Romans 8:18 through to 23. But it's in verse 20 where it talks about how this law of decay pervades the entirety of the universe. It's everywhere. And it's everywhere in time and everywhere in space. And it's something, there are 7 places in the Bible that tells us the laws of physics are constant. They don't change. And it's something we astronomers have been measuring to high precision. So we look out throughout the universe at all different times in the past history of the universe, and every time we look at the spectra of a star or a galaxy, we're measuring the laws of physics. And it's such that we can affirm that the laws of physics are changing at a rate of less than 1 part in 10 to the 18 per year over the entire history of the universe. So we can demonstrate that temporally, we can also demonstrate that spatially. Everywhere we look in the universe, we see that the same laws of physics are in operation. But if you read on in Romans 8, when you get to verse 23, it tells us that this law of decay will remain pervading the entirety of the universe up until the time that the total number of humans that God intends to redeem have been redeemed. When that full number has been reached, that's when the law of decay will cease to exist. And I'll be talking about this in my message plenary session this afternoon, how a time will come when there will be no thermodynamics, but not until the full number of humans that have been redeemed, in fact, have been redeemed. So yeah, you're going to have to put up with thermodynamics until that point is reached. But here's the good news. We're close to reaching that full number. Go ahead.
Dr. Ross, what do you say to the global warming crowd that says there's too much carbon and the planet's going to be uninhabitable in 10 years?
Well, I wrote a book called Weathering Climate Change. It may be at the table, I don't know. But I wrote the book in response to people who are saying that the planet is warming, the climate is becoming unstable, and we need to take drastic measures to restore climate stability. And my response was they're ignoring two biblical principles. Principle number one, we human beings are fundamentally selfish. So trying to pass laws to force people to make draconian economic sacrifices won't work. Some people will be altruistic and say, yeah, I'm going to do it. I'll sacrifice my standard of living by a factor of 2 if that's what it takes, but other people will cheat. One nation may go for it, another nation will choose to cheat. It's not going to work. Principle number 2, God gave us a command that's in the first chapter of Genesis. I'm putting you in charge of planet Earth to manage its resources for your benefit and the benefit of all their life, which implies that we will find win-win solutions. Ways that we can restore climate stability where we not only benefit the human economy, but we also benefit the world's ecosystems. And so I filled my book with those win-win solutions. And I do agree with the global warming people that we've got a problem. For 9,500 years, we had extreme climate stability. I mean, if you look from 9,500 years ago until 1950, the global mean temperature was stable to within plus or minus 0.65 degrees. In fact, for the previous 1,000 years, it was stable to plus or minus 0.06 degrees. And so from the year about 900 up until 1950, that was a period where we saw technology and civilization, the population rapidly advancing. It was all possible because we had this extreme climate stability. And a point I make in my book, what we've been experiencing for the past 9,500 years is the exception. The norm for planet Earth is climate instability. But because of incredible miraculous interventions, we've had this period of 9,500 years of extreme climate stability. But what's been happening, and by the way, what's been going on in the last 10,000 years, natural cycles have been cooling the planet. So the Earth's rotation axis tilt is changing to make the planet colder. The shape of our orbit is changing to make the planet colder. But human activity did the opposite. It was making the planet warmer. And for 9,500 years, the human warming effects were perfectly balancing the natural cooling effects. But what's been happening since 1950 is that our technology's been exploding and our population's been increasing, and consequently, for the first time, human warming activity is outstripping the natural cooling. And so the temperature's risen by 1 degree centigrade, which is not a problem. A problem would be if it goes up by 3 degrees centigrade. And we live in an ice age cycle. And we see in that ice age cycle is that when you go from a glacial to an interglacial, the temperature gradually goes up. And when it gets to about 2 degrees centigrade above where it is now, the polar ice cap melts. And when the polar ice cap melts, instead of sunlight being reflected with 60% efficiency, it's now reflected with only 6% efficiency, which means the Arctic Ocean absorbs a lot of heat from the sun. What happens to that heat? It makes snow that falls on Siberia and Canada. And so here's the paradox. Global warming always brings on global cooling. If you melt the polar ice cap, you very quickly put thousands of feet of ice all over Canada and Siberia, and that brings about a global cooling effect. It also restores climate instability. During the last ice age, the global mean temperature was going up and down by 18 degrees Fahrenheit on time scales of just centuries, which explains why during the last ice age, the human population remained low. They didn't have the climate stability to grow an abundance of food. And without an abundance of food, you can't set enough of the population free to do engineering and science and art and music and literature, etc. So, but what I put in my book is ways we can bring about climate stability while we boost the world's economy, and especially for the poorest people of the world, and at the same time we enhance the ecosystems of the world. For example, that we have people today saying we have to eliminate all fossil fuels. Well, that's going to take time, a lot of time, to find alternate energy sources. What's being overlooked is that If we could just simply say, we're going to stop burning coal and we're going to replace it with natural gas. The natural gas is cheaper than the coal. And when you burn natural gas instead of coal, you immediately reduce the greenhouse gas emissions by a factor of 2. You get a 50% drop in greenhouse gas emissions just with that simple step, and it's an economic blessing to the planet. It's also a blessing in the sense that there's no black carbon soot and there's no sulfur aerosols, so the atmosphere gets clear. And Canada is warming up 5 times faster than the rest of the world, and it's not because of carbon dioxide. That is a factor, but the biggest factor is black carbon soot being blown up from India and China and being deposited on the Canadian North. If we could actually tell the Indians and the Chinese, how about if we sell you natural gas for less than what you're paying for the coal? And immediately the atmosphere would clear. If you're in New Delhi, you can't see a single star on a clear night, but get rid of those sulfur aerosols and that black carbon soot, you'd be able to see stars again. And you wouldn't have the respiratory diseases that they're experiencing. And my whole point is, if we were to do that, it would buy us the time we need to actually institute thorium nuclear reactors all over the world. People are against uranium nuclear reactors for many good reasons. But with thorium nuclear reactors, it's impossible to have a meltdown. It's impossible to use the thorium reactors to make weapons. You can't make weapons. If you try, it'll kill you. It produces energy potentially for half the price of hydropower, which is the cheapest source of energy on the planet today. And we live on a planet that's got 630 times as much thorium as any other rocky planet. It's cheap to mine. You don't need special equipment to mine it. What about the radioactive waste? They're safe to touch within 50 years. With uranium, it's 50,000 years. With thorium, it's just 50 years. That's just 2 examples. I put 40 examples in the book of things we can do that will bless the world's ecosystems, the plants and the animals, and at the same time enhance the world economy, bless the poor people of the world, and at the same time it restores climate stability.
Can you add just an addendum to that? What is the time horizon? Let's say none of the things that you suggest that could really make things better are adopted. And there's a lot of gloom and doom with regards to the near future as a result of climate change. So I'm wondering if you think that's exaggerated, or what's the event horizon if nothing changes significantly in the way we do our energy?
Well, I'm going to be doing a debate on this next month, actually, with some climate change alarmists. And I think alarmists talk actually makes people do less. People get panicked and they wind up not doing the right thing, or they do things that have unintended consequences. But I do agree with their claim that this is an urgent crisis. For that reason, I'm saying we can't use taxes and penalties to try to force people to do things that are counter to their best interests. They will delay, they will dig in their heels. But if we can give them solutions where we say, hey, if you put your money here, you're going to get a 20% return on your investment per year, they're going to do it tomorrow. And so, yes, I think the time scale, I would say, we need to do something serious within the next decade. If we wait more than a decade, it'll be too late. And the thing to watch for is what happens to the winter polar ice cap. The summer polar ice cap is being degraded, but not the winter polar ice cap. There's nothing to worry about right now. But if we see any degradation in the winter polar ice cap, then we need to do something. And we really need to do something before that happens. Because once you see snow and ice accumulating in western Siberia and Labrador, it'll be too late. And we're already seeing some signs in Labrador, but not, or some signs in Siberia, but not Labrador.
Okay, cash out too late for me. In other words, what if we wait and it's too late, what actually happens to civilization then?
Well, for a while, things will get warmer, which is not going to disturb things too much. But if the next ice age comes in and all of Canada begins covered with snow, not a problem. The Canadians can move south, but keep in mind, during the last ice age, the port of San Diego was frozen over for 6 months of the year. That's how far south it came. I mean, Yosemite Valley was covered up with ice. So a good chunk of the United States will be affected. And then you got all those Canadians looking for a place to live, right? And everybody's going to be moving to Phoenix, but not everybody can live in the Phoenix area. So yeah, it will be catastrophic. It's in our own best interest to delay the onset of the next ice age. Now, we can't put it off forever, but I do argue we could put it off for 1,500 years. But if we're not careful, we could see it beginning to come upon us before the end of the 21st century. And I'm basically saying there's economic good reasons why we should solve this problem and solve it now. One of the fastest things we can do, stop coal, go with natural gas. That's something that can be instituted within a year and have an immediate benefit. And then we can gear up for thorium nuclear power reaction. That can be done in a decade. And that would provide all the energy that the world needs for the next couple of thousand years at a price that's cheaper than any source of electricity that we have today. So we do have solutions. We can replant the Sahara Desert. There's a better way to lumber. I'm basically advocating we need to bring the lumbering companies into the national parks and national forests during the winter months when the tourists are not there, where they harvest out the big old trees that are in danger of dying. If we let them die, they release greenhouse gases to the atmosphere. If we replace them with young trees, those young trees will pull greenhouse gases to the atmosphere at 2 to 4 times the rate that the old trees do. And that's going to benefit the wildlife there. The forests are going to look beautiful again. They'll look green rather than orange and red. The tourists are going to love it. They can actually charge more money for tourists to come into those places. I mean, this makes economic good sense. And moreover, it fits biblical principles, encouraging people to do what's in their best interests, and also realizing God has given us the resources to manage the planet for our benefit and the benefit of all of their life. It's win-win. Okay, I see I'm out of time, so I'll let you all go. Thanks.